Dear students, welcome back. Our today's topic is area between two curves. In this lecture, we want to know how can we calculate definite integration in order to calculate area between two curves. So here, first of all, you need to know area formula of definite integration. Let's try to understand this one. Suppose this is our x-axis and this one is y-axis. So area under this curve from x equal a to x equal b is this. This is our function y equal to fx. Now the question is, what is the area of this region? By the help of definite integration, we can write area A equal integration from A to B fx dx. So area under a curve we can calculate by using this formula. And here I should say something first. আমার কিছু ছাত্রদের রিকোয়েস্টে আজকে আমি কিছু বাংলা কথা বলতে পারি এই লেকচারে। So the first question is where this formula comes from. Area A equal integration, this is the lower limit of integration and this is the upper limit of integration, and this is our given function. So area under this curve is this formula. Now the question is where this formula comes from. This interval here, your interval is from A to B. So if you divide this interval into n small strips, then you will get lots of small strips here, like 1, 2 and so on up to n. So let us consider this small strip at x star. Let's say this is at x star. So at x star, if you divide this region into, let's say, 100 times, then interval will be very small. তুমি যদি আরো বেশি সংখ্যক ভাগে ভাগ করো, let's say 500, 5 billion, 5 trillion, then the width, this delta x will tends to 0 when n tends to infinity. অর্থাৎ তুমি যখন অসংখ্য ভাগে ভাগ করবা তখন উইডথটা অনেক ছোট হয়ে যাবে. So it will be approximate to 0 when n tends to infinity. Now if you take in that case when n tends to infinity, delta x tends to 0, in that case this small rectangle, it will be a small rectangle. This side will no longer be a curve. So it will be a small rectangle, and the area of this rectangle will be what? Will be length at x star. The length will be f x star. This is the length, and width delta x. So this is the area of your this small rectangle. Now here, if you have n rectangle, then you can sum up the area of all rectangle. So in that case, n equal to, let's say, xk. This is xk. So this is the k strip. In that case, let's say k equal to 1 to n. So this is called Riemann sum, and if you take a limit here, limit either n tends to infinity, or you can write delta x tends to 0, any one you can write. In that case, this formula will give you this one, integration, definite integration, a to b fx dx. So instead of delta x you write, instead of delta x you write dx, and instead of fx star k you write fx, and instead of this summation sign you write this integral sign. So this is how you can make a relation between Riemann sum and definite integration. If you want to calculate area between two curves, let's say the first curve is y equal to fx, this is our first curve, and the second curve is this one, which is y2 equal gx, this is our second curve. And now if you want to know area between two curves, it means if you want to calculate area of this irregular region, let us consider this region by A, then how can we do that? You just need to subtract g from f, because f is greater than g, it can be equal, f can be greater than or equal to g, and this region need to be bounded. The area, the region you want to calculate area should be bounded above by this, above by a curve and below by another curve, and above one will be greater than the below one, because তুমি যত উপরের দিকে যাবা y ততই বড় হবে, সেই কারণে উপরের কার্ভটা হবে বড় নিচেরটার থেকে। So let's say if you want to know area below y1 equal to fx, then this one will be your area. But if you want to calculate area between fx and gx, then you need to subtract this region from the whole area. So we need to subtract this white region from the whole area. So that's the reason you need to subtract gx. So the area of this white region will be integration from a to b gx dx. So if you subtract this white region from the whole region, then you will get area of this irregular region. And note that this region is bounded above by y1, below by y2, and left by a line which is x equal to a, which is also lower limit of your integration, and x equal to bounded right by another line x equal to b, which is your upper region, upper limit of your integral. So you just it's not so difficult to, if you want to know area between two curves, it's not so difficult. You just need to subtract one function from the upper one and integrate it from the from x equal to a to x equal to b, and x equal to a is the left line, x equal to b is the upper line. Although this line can intersect each other like this. Let's say if you want to know the area of these two curves from x equal to a to x equal to b, so in that case you just need to calculate point of intersection. Here the region is bounded above by y1 and below by y2, but left by their point of intersection x equal to a, and right by their point of intersection x equal to b, or it can be bounded left by a line, right by a point, or left by a point, right by a line. So you see here area formula 1 we are integrating with respect to x, and there is another formula which is I said area formula 2, and here you need to integrate with respect to y. Why? Because your here the region you want to calculate area should be bounded right by a curve and left by a curve, below by a line, up bounded above by a line. So here in the previous case your curve was above and below, but here you will use formula 2. If your curve is bounded, if your region is bounded right by a curve and left by another curve, so the curve which is in the right is the larger one. Here x1 is greater than or equal to x2, because the curve which is in the right side will be greater than the curve which is in the left side. Okay. So the lower limit of integration will be y equal to c, and upper limit will be y equal to d, and you need to subtract the left one zy from the right one fy. So you see integration from y equal to c, y equal to d, fy minus zy, and you are integrating with respect to y. So like the previous one, it can be bounded below by either a point or a line and above by a point or a line, but left and right by two curves. So in this lecture I will try to show you some examples examples by using formula 1. We will try to understand how can we calculate area between two curves using formula 1. So now let us try to understand example 1. It says find the area of the region that is bounded above by y equal to x plus c and bounded below by y equal to x square and bounded on the sides by the lines x equal to 0 and x equal to 2. So here we have two curves, y equal to x plus 6, y equal to x square. First you need to draw them. You can easily draw this curve by considering any 2 points from here. For example, here you can calculate 0 when x equal to 0, y equal to 6 is a point, and another point let's say when x equal to 1, y equal to 7. So you can consider these 2 points and then extend both sides to draw y equal to x plus 6, or in other way you can just by looking on this curve you can understand the y-intercept is 6 and slope 1, so you can easily graph it. And y equal to x square is a parabola having vertex at the origin and which is open up. But to draw this one you can also consider 0, 1, 1, minus 1, 1, 2, 4, minus 2, 4. So this is the graph of the given functions, and here in this example you want to calculate area between these two curves but left by x equal to 0. So this is your left line x equal to 0, and another one x equal to 2, which is this line. This line is x equal to 2 line. So in this problem you want to know area of this region. So by using our formula 1 is this one. Here we will use formula 1 because your region, if you move any point on this region, if you move up you will get the line y equal to x plus 6, and if you move down you will get the curve y equal to x square. So this curve is the above one and below one is y equal to x square. So here your area will be, the lower limit is x equal to 0 and upper limit x equal 2, and your curve above one is this one. So this one is y equal to x plus 6. So you just need to write x plus 6 minus x square. The lower curve is x square and you need to integrate with respect to x. So just you just need to calculate the do some simplification. Let me write it: x square by 2 plus integration of 6 equals 6x minus x square equal x to the power 3 by 3. So lower limit and upper limit 2, this equal 4 by 2. If you first put, you just need to put the upper limit first here, then the lower limit. If you put lower limit, this one will be 0. So by putting the upper limit, we can write 12 minus 8 by 3, which is equal 6, 12 plus 72 minus 16. So this equal 84 minus 16 divided by 6, which is equal 68 divided by 6, which is equal 34 divided by 2, 34 divided by 3. So this is the answer. Okay, so let's try to understand example 2. Find the area of the region that is enclosed between the curves y equal to x square and y equal to x plus 6. The curve is same curve which was in example 1. So here you are not given the lower limit of integration of or upper limit of integration. You just need to calculate, since you need to calculate the area between two curves, so you need to calculate their point of intersection. So, and in this problem you need to calculate area between two curves. It means you need to calculate whole area from this point of intersection to this point of intersection. So how can we do that? How can we calculate point of intersection first? So by solving two equations, you can calculate point of intersection, which is, since y equal to x square and y equal to x plus 6, y equal to x square and y equal to x plus 6. Therefore, you can write x square equal x plus 6. This implies x square minus x minus 6 equal 0. By factoring, you can write x square minus 3x plus 2x minus 6 equal 0. So x minus 3 plus 2 into x minus 3 equal 0. This implies x minus 3, x plus 2 equal 0. Therefore, x equal minus 2 and 3. So, when x equal to minus 2, y equal 4. And when x equal to 3, y equal 9. So, the left one will be minus 2, 4. And the right one will be 3, 9. So you see this point, the coordinate of this point minus 2, 4 and coordinate of this point minus 3, 9. So since you are going to calculate area of this whole region, your lower limit will be x equal to what? You see x equal to negative 2. So lower limit will be x equal to negative 2 and upper limit will be x equal to 3. So x equal to 3, and that's all. You just need to subtract the lower one from the above one. So now by doing some simple calculation, you can easily evaluate it by yourself, and the integration of x square by 2, x 6x minus x3 by 3, lower limit minus 2 and upper limit 3. And if you put upper limit here, I left this work for you. If you put upper limit instead of x, then you will get 27 by 2 minus, if you put lower limit which is minus 2 instead of x, then you will get minus 22 by 3, and the final answer will be 125 divided by 6. So this is the area between these two curves. So let's try to understand example 3. It's very interesting example, and this is also important for several exams. Find the area of the region enclosed by x equal y square and y equal to x minus 2. Here also you need to calculate area between two curves, so you need to calculate their point of intersections. So first let me say something about how can I sketch these graphs. First of all, we understand that x equal to y square is a parabola which is open right and vertex at the origin. If you don't understand it, you can convert this equation into this form, which is y equal to plus minus root x. If x equal to 0, y also 0. If x equal to 1, y equal plus minus 1. So when x equal to 1, y 1 and minus 1. And the previous point is this one. And again, if x equal to 4, y equal plus minus 2. So 1, 2, 3, 4, 1, 2. This point is nothing but 4, 2. And this one, it will be probably like this. So this point is nothing but 4, negative 2. And y equal to x minus 2, it's a simple straight line, and y equal to x is this line, and negative 2 means it will passes through this point, so it will be like this. So and this point also 0, 2, 0, and the coordinate of this point 0, negative 2. So this is our line y equal to x minus 2. So this is how you can sketch these graphs. And now let us try to understand how can we calculate point of intersection of these two curves. Since x equal y square, so I can write y square and x equal y plus 2. So I can write y square equal y plus 2. This implies y square minus y minus 2 equal 0. By factoring, I can write y square minus 2y plus y minus 2 equal 0. Y minus 2 plus 1 times y minus 2 equal 0. This implies y minus 2, y plus 1 equal 0. Therefore, y equal negative 1 and 2. And the corresponding value of x will be anyone you can use. If x equal, y equal negative 1, x equal to 1, y equal to 2, x equal to 4. So we have 2 points of intersections. One is 1, negative 1, another one 4, 2. 4 and 2. So this is our first point, 1 minus 1. And this is our second point of intersection, which is 4, 2. So this is how you can calculate the point of intersection between of two curves. But the next question is, how can we calculate area? You see, this region, if you want to use formula 1, this region you need to divide into two parts, because if you consider this point and move up, you will get this line, which is y equal to root x, and from here to this line is nothing but y equal to negative root x. So from 0 to the positive 1, y equal to root x, and from here to here y equal to negative 2x, root x. So if you move up, you will get root x. If you move down, you will get y equal to x minus 2. From here, if you move up, you will get root x. Move down, you will get the straight line. From here, you will get the same curve. From here, you will also get the same curve. But when you cross x equal to 1 and move up, you will get root x first, and if you move down, you will get negative root x. So if you want to know the whole region, area of the whole region, you need to divide this region into two parts at x equal to 1. And you need to divide it here and calculate separately area of this region, let's say A1, and area of this region, let's say A2, this region, let's say A2. So the whole area A will be A1 plus A2. So I think all of you understand why I divide this region into two regions. Let me say it again. If you move up, you will get this curve for this region, and move down, you will get a straight line. But left of this line, the scenery is different. If you move up, you will get root x. If you move down, you will get negative root x. So you need to calculate separately area. So for the A1, your lower limit will be what? Here x equal 0, and here x equal 1. So your lower limit will be 0 and upper limit will be 1, and the curve above 1 is root x minus the curve below 1 is negative root x. So it will be negative root x, and you need to integrate it with respect to x, plus for A2 your lower limit will be the same point where the first part end, the first region end at x equal to 1. So your second region start at x equal to 1 and end at x equal to 4. End at x equal to 4. X equal to 4. So your lower limit will be 1 and upper limit will be 4. And the curve for this region above 1 is nothing but root x. Root x minus the curve lower one, is nothing but this straight line, which is x minus 2. X minus 2 dx. So now the calculation is simple integration. You see, if you add this 2 root x plus root x, you will get 2 root x. So let me write 2 out of this integral sign, 0 to 1, or first let me put it inside the integral sign, 2 root x dx plus 1 to 4 root x minus x plus 2 dx. And the integration is very simple. You see, x to the power half plus 1, it means 3 by 2 divided by 3 by 2, lower limit 0 to 1, plus root x, x to the power half plus 1, 3 by 2 divided by 3 by 2 minus x square by 2 plus 2x, 1 to 4. Now from here you can easily do this simplification by yourself. You see, when you put upper limit here, it will be 2 times 2 by 3, it will be 4 by 3. If you put upper limit and lower limit, it will be 1 minus 0 plus 4. If you put upper limit, it will be 4 to the power 3 by 2, it means 2 to the power 3, it means 8. So 8 divided by 3 by 2 minus 4 square, 16 by 2, 8 plus 4, 2 times 4 equal to 8. Minus, if you put 1 here, you will get this, and this one will be this. If you do this simplification by yourself, you will get 19 by 6, and you have 4 by 3 here. So 4 by 3 plus 19 by 6 equal to 9 by 2. So this is the answer. So that's the end of this lecture, and in this lecture we used formula 1 in order to calculate area between two curves. In our next lecture we will use formula 2, where we will integrate with respect to y in order to calculate area between two curves. Hope you enjoy this lecture and hope to see you in the next lecture. Thank you very much.